to turn on your camera for the attendance lang. Okay, screenshot. Pwede na. Can you turn on your cameras for attendance? If you don't have camera, okay lang. Okay. For those who have, please turn on to just screenshot lang. Ako. Kadyo to dito. Okay raw, okay ligo, okay raw, okay muta. Okay raw, like, so kato lang na, okay, atong ikuan, please. At least I, uh, okay, mo screenshot for the attendance lang. Thank you. Okay, so I'm capturing right now. Thank you. So capture na, so you can turn it off. Okay, so we can turn off your camera. Pwede na. Okay, can you see my camera screen?
Yes, sir.
Okay,
Yes, sir.
so let's start with right away because we're going to do all the series of critical discussion on for our night. Okay, so likely when we go to the laboratory now, we're going to do also the lab activities. Okay, so actually module one is a civil area OSP of 52 concept. I think this is also covered from if you're using version 6 Select Archive. Okay, if you're using older versions of Select Archive as module 2, I think this is being covered. Okay, so civil area OSP also for dynamic so module 3 is more about the enterprise networking, enterprise security, and application. Okay, so this would explain how the civil area operates in both point-to-point and also for multi-access network. Okay, this would describe the aspect features and characteristics, describes the packet types used in the civil area OSPF, and how the civil area or OSPF operates. So first is the features and the characteristic for OSPF. So OSPF is a link-state routing protocol that was developed as an alternative for distant vector technology. So OSPF has significant advantage over the RIP that it offers faster convergence and scales to much large network implementation. Okay? So OSPF is a link state routing protocol that uses a concept of areas, define more areas, okay, which are gonna belong sa dynamic routing, okay, and an administrator can divide the routing domain into a distinct area that help control routing update traffic. So a link is an interface on a router, a network segment that connects two routers or a stub network such as Ethernet LAN that is connected to a single router. The information about the state of a link is known as a link state. So all link state information includes network prefix, information, the length of the prefix, and the cost that takes from one router to another. So remember, the cost is very important. Yung muna akong masihan na kung sa'yo pinaka-best path. So the lower the number of costs, the best path it is. Okay? So matter din ang atong link speed, ay yung JGN ng mga networks, okay? Pila yung link speed and also pila ka-hot between them. So this modules just covers only the basic part of the single OSPF implementation and configuration. Okay? So in case that you have any question, please don't. You can just raise your hand. Okay, you can raise your hand so that you can pause for a while, then answer your question. Okay. So the components for OSPF is that all routing shares similar components. They all use routing protocol messages to exchange route information. Okay, the messages help build data structures which then process using the router algorithm. So routers running OSPF exchange message to convey route information using five types of packet. Okay? So when you're going to put up an OSPF, define the area, these are the packets and these are the messages that are being sent, okay, to make converge with other router. Okay, so first we have a hello packet, then we have the database description packet, the link state request, the link state update, and the link state acknowledgement. So these packets are used to discover neighboring routers and also exchange routing information to maintain accurate information about the network. So for the messages are used to create and maintain three OSPF database as a file. Okay, so what I call the adjacency. Okay, so this is usually a list of neighboring routers to which router has established bidirectional communication. Okay, so when say adjacency, they both the router can also be nagkita as well. Okay, provide us like link between them. Okay, so this table is unique for each router. Okay, can be viewed using the show IP or SPF command. Okay, so every router has different information inside its own neighboring table. Okay, for example, R1, then we have example now, we have three routers. Okay, for R1, you will have see the adjacency data or the neighbor table in which you can see the R2 and R3. For R2, you have the R1 and the R3. For R3, you have also the information, adjacency information of the R1 and R2. Okay, so it will differ from if you're having the information of other person. Okay, so you have the link state database, or this is short for LSDB. Okay, so usually link state database is like a topology table. This is a list of information all about the routers in the network. So the database represents the network LSDB. So all routers within the area, okay, within the area that are the same and sharing the same area number or area, okay, we have identical LSD. Okay, so all information within the area have the same information on the instant database. So this can be viewed using the show IP OSPF this command. Okay, then we have also the forwarding database. Okay, so yes, Miss Daniela. Yes, Daniela, you have question. You can type if your so your mic is not working. You can also type it on the chat. Do you have a question? Daniela? Mas Daniela? Okay, let's continue. We have forwarding database. Okay, so forwarding database is usually the routing table. Okay, you know what's the routing table do. Okay, so that is the main important part information of the router. Okay, so remember the function of router. Do you remember what is the function of router? Anybody? The function of the router. Okay, let's call someone, Sinisa. Uh, can you hear me, guys?
Sir,
Yes, Sinisa. Do you remember what is the function of router?
wala na sir.
Wala na. So usually router is usually the one who provides connectivity between networks. Remember, if you need to communicate with other network, router itong kailangan, di ba? Now sa tela ay na device na intermediary device which is tawag to switch. Ang switch is umpad. Do you know what is a switch? Anybody? Isa ganahan mo save sa iyong classmate, labaho. Okay, it's just review lang eh. Wala, may mic. Di kayo maklaro ang audio. Ako ang audio. Test mic, 1, 2, 3, 1, 2.
Excuse me sir. Di kay maklaro imong tingog sir.
Kung saan ka choppy?
Kuan sir kanang murag lubog o. Umbot. Dili man siya choppy sir.
Hindi siya choppy.
Clear.
Murag
Wala
kanang
kayo.
kuan sir kanang hanap ba?
Let me check kasi nakalit. 1, 0. Microphone is using. Test mic. 1, 2, 3. Kani, how about this one?
Yes, sir.
Kana
Kana,
sir.
sir.
Kana sir.
Okay, thank you.
Okay na siya, sir.
So, ang mic di gamit sa camera di mo de. Kilayon gamay ang camera. Okay? So anyway, again, balik ta dito as a review. Do you remember the function of the router? Sinisa?
Yes sir.
Yes. Please, can you describe the function of our router or what do you understand about the router? What does it do sa atong network?
Kuan sir. Kanang receives and send data on computer sir.
Mm, all devices do that, di ba? But what does the router do specifically that separates the other? That siya rin mo buhat, ana?
Mga tawag IP address eh.
Okay, actually that is additional service, di ba? Add-on service for a certain router. Okay? That could be okay, but when you say router manggod, usually router is the one who connects to a network. Okay? So, if your PC wants to communicate with other computer na nabilong sa lain na network, that's the time you need a router. Pero if you're going to communicate with a PC to another PC within your network, you don't need a router. So router is usually the bridge for other networks. Okay? So, for example, sa balay, you have computer, you have the laptop. Okay, you can all share the devices. You can share the photos, music, and so on. Okay, that is true within your local area network. Okay, your communication between other computers within your home PC or your home devices are through the local area network lang, which means ang switch ay di gamit ana, switching lang. Okay? Ay mong data and travel to the switch. Pero if ever you're going to access YouTube, if you're going to access other services beyond sa imo ang balay, that's the time we need a router. Okay, without a router, we cannot communicate with other networks. So, mo na siya yung main function sa tong router. Okay?
But we know that router have some features that are very useful sa, for example, mohatag IP. Okay, that's correct. We're done. Okay, so you can provide IP. It can also do uh, NAT, routing NAT, or publishing service. Okay, so dagang mabuhat, dagang extra features. Okay, for giving out the IP, that is just minimal na feature na pwede mabuhat sa router. Okay, okay, so we'll continue with the forwarding database. Okay, so for the forwarding database, usually we have the routing table. The routing table is the most important part of our router's configuration because without the routing table, your router is useless. It doesn't know where to route, to send, to move packet from one network to another. So muna timaniha ba sa router ang movement gid sa packet between or with other networks. Ang switch is ang movement ana niya is within local raman, local area network. That's why ang router, nana siya belong sa mga WAN devices, di ba? WAN links, na siya WAN links. For the switches, nana siya sa tawagon na LAN. May kag LAN, local area network, or LAN, nasa LAN. Wala siyang switch because the switch is the one who provides network connectivity within your network. Within your network. Okay? Router provides connectivity with other networks. So, big difference between the switch and the router ha, ay mo kalibog. But uban ron pareha ng pakapin sa PLDT, Globe, and Converge, hatagan kanilang modem router, di ba? Modem usually modulates and demodulates your connectivity signal. If they have fiber, usually demodulates sa fiber kanang signaling sa iyong fiber into digital sa imong Ethernet type na connectivity. Okay? So not only it provides router, it also have a switch connection. Sa luyo, di ba? Kita kag upat ka port, color yellow. The other one is kanang naglahi diha kay blue. Usually naan ang color coding. So the blue one is your link to outside, which connects to other network. Kanang yellow, kanang LAN, indicate na LAN, that is your local area network, which means that is your network within internally. Okay. For the forwarding database, this is a list of routes generated when an algorithm is run on the link state device. So each router's routing table is unique. Okay, it has a different routing information for every devices. Okay, same with the adjacency database. Okay, so each routing table is unique. It contains information on how and where to send packets to other routers. Can be viewed using the show IP route. So I think familiar morning show IP route, no? John, are you familiar with the IP route, show IP route?
Yes, sir.
Okay,
Yes,
so
sir.
what does the show IP route display? Ano say ma-remember nimo?
Ipakita tanan IP nga naa sa network, sir.
What kind of IP?
Ang mga IP sa nga naa sa network nga na-discover sa router.
Not totally na IP na discovered. When you say IP, it means that mura kag describe ka og specific isa ka device or isa ka identity na IP. Okay? What you see sa imong routing table are usually a networks, mga addresses sa networks. So you have the network information, the network address, then it correspond with katong parameters, okay? Administrative na distance, okay? Sa asa siya mogawas, unsa na interface, or through what router, asa siya moagi para makaabot ang destination. So usually mo na yung information na sa imong router. Okay, that's why this is very important because without your routing table, your router cannot act as a router. Okay? Muna yung basihan pag-route, pag-move sa packet to other network. That's why suit sa imong routing table are usually the network addresses of your neighboring routers. Could be neighboring routers or could be your destination networks. Usually, nada ang mga network addresses na information. Okay? Okay, so katong siguro ni-mention mo na IP address, usually mo na siya makita nimo sa imong router if it provides IP addresses sa mga local area network na machines or SIM LAN. Okay? So once it provides IP address, mo display dito unsay na provide niya. Okay? That is just for the extra features. It's for the DHCP. Okay? So the HCP is the one is a service that provides IP address for your local network. Okay, so we'll proceed with this one. Okay, after components with OSPF. Any other questions? Questions? What may kuan? Additional questions? Okay, so let's proceed. Okay, so router builds a topology table using the result of calculation based on Dijkstra shortest path or SPF algorithm. So this algorithm is based on cumulative cost to reach the destination. So this creates an SPF tree by placing each router at the root of the tree and calculating the shortest path. Okay. So this tree is used to calculate the best route. Now SPF places the best route into the forwarding database, which is used to make the routing table. Okay. So it creates what we call kana marmitog tree. For example, as a nag-start from each router, that's why every router have different routing table. Okay, so from router one to next router, okay, what would be the cost? Okay, there will be a possibility that you will have a multiple path for that destination router. That's why it's going to get the best spot or the shortest path to each node, the lowest cost of each path. Okay. So to maintain routing information, OSPF router complete a generic link state routing process to reach the state of convergence. The following are the link state routing steps that are completed by a router. First, it will establish neighbor adjacency. It will be detected that there will be a router adjacency, exchange link state advertisement. Then it will build the link state database. Then execute the SPF algorithm and choose the best route. Okay. So to make the OSPF more efficient and scalable if you're going to build up, start from small, then it will scale up to bigger network. OSPF supports hierarchical routing using areas, what we call areas. So OSPF is usually based on area grid definition. So area is a group of routers that shares the same link state information in their LSDP, in their link state database information. So SPF can be implemented in one or two ways. Pwede single area OSPF where all routers are in one area. Okay, best practice is to use the area 0. Nasa tayo tawag na multi-area. Okay, usually common is siya sa mga dagko kay mga company in which they have a lot of branches. Okay, they have offices branches from other area, like for example Manila, Cebu, Hong Kong, Tokyo, US. Then all of the services are being provided using the OSPF routing. Okay, so OSPF in implementing using multi-areas in hierarchical fashion, all areas must connect to what we call a backbone. Okay, so define nga po ng area 0 for OSPF as your backbone. For single area OSPF, isa ra ka area ang ma-define na to because single man. Okay, for multi-area, usually we need to define our area 0. Okay, so routers in connecting the areas are referred to as an area border routers or ABRs. The focus of this module is usually for single area na OSPF version 2 for now. Okay, so multi-area OSPF topology design option with the multi-area OSPF can offer the following advantages. Okay, so it has smaller routing tables. The tables are smaller because there are fewer routing tables and trees. This is because the network address can be summarized between area. Okay, so I think nanin sa yung module 2, route summarization. Remember pa mo? Okay, so if you have a destination network that have the same path, for example, network na 192.168.1.0/24 is padong to through interface serial 1, 192.168.2. 192.168.2.0/24 is also the same path on also 192.168.3. Okay, let's say those three network destination have the same path pero dili sila pareha og destination network. Okay, so those destination network can be summarized into one. Okay, one destination. Okay, di ba? Kwaon nimo ang common. Okay, so let's have a review daw gamay. So, do you remember how to identify the network, right? Okay, let's have the how we call this. Can you take the wait let me stop sharing this and have a notes. Okay, so can you see my notepad? So example, if you have 192.168 1.12/24. Okay? You would know unsa atong kuandre, di ba? So you would know na unsa atong network. Can you remember? Can I ask na lang? Fernandez. For this example na IP, can you identify what network does it belong? Fernandez.
Wala, sir.
Okay, so we have a /24 here, which means the first 24 bit is for your the host side, which means this is your network. Diba? So if you're given like this one, this is a host address, which is the .12. But atong network ani would be 192.168.1.0. Okay? So if we have another network side, let's say another network na 192.168.2.0, then another network na 192.168.3.0. Okay? These destination networks can be summarized into one. Okay? So, saan nito pag-summarize? Okay? May tao na to ang common. So, murag ka ng sa math subject na sa common denominator. Diri, may tao na to as latanan pareha. Okay? So, remember in IP addressing, these are all binaries, di ba? If ever we're going to kuan lang, ignore tani ang first two octet, ato ni siyang i-convert ang third octet, which is ang 1 is 0. Sorry. Wala ito pat na may. Ito i-convert ang third octet. Dili ta mag-start since obvious naman kayo na kaning first two are all the same, di ba? So, ang buhato na ni is convert na tong 1. That is 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Di ba? Do you agree that is correct? First one? How about 2? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that is for the 2 na network. And the 3 network is, this is very easy, di ba? Okay. Di ba makita na ninyo ang alignment as sila pareha tanan as sila nag-differ. So remember, ang nasa left side is your network. Same ganina na kung ningo na this is our network based on the prefix 24. But if you're going given this with this network addresses, duha ka book, pwede sila masummarize into one. So unsa may common nila? Kani, padong sa left, padong sa left. Ang padong sa right is different. Diba? So what will happen is to summarize this one, you can rewrite these three as a summarized na address as 192.168.0.0/. Since na niya muna niya itong bagong divider, this would be the slash 22. Question. So if ever you're going to put this on your routing table, inigbasa sa router ani, kani siya na network na belong ani. Even though sa atong actual network setup is kani siya different network, kani siya different network, this is also different. This one describes all these three, plus including others. Okay? So, mo siya tawag ng summarize na routing. Okay? Question? We'll proceed with the other topic na to. Okay? Do you want a break or something? Let me know if pas-pasta or unsa. Or do you have a question? Wala ra ba yung comment or nangatog na mo? Kasi nakatog na mo ha. Okay, so small routing tables, that is example nato to be ang atong routing table, some of the routes will be summarized. Okay, so this is because network address can be summarized between areas. So route summarization is not enabled by default. Okay. Next is reduce the link state update overhead. So designing a multi-area OSPF with the smaller areas, minimize the processing and the memory requirement. So every time na natay dipadagan ng mga, for example, OSPF, usually it is used CPU utilization and also sa atong memory sa atong mga routers, okay? Because kailangan naman siya algorithm na kailangan i-compute, okay? It reduces frequency of SPF calculation. So multi-area OSPF localize the impact of topology change within an area. For instance, it minimizes routing update impact because LSA flooding stop at the area boundary. Okay. So for example, this is our example for the multi-area where we have to define area 0 as usually default na natay area 0 is single area, area 0 ra gyud atong gamiton. Okay? So here we have area 1 and area 51. So between area 1 and 51 na belong na nasto nga ang ato ang area 0. Which is ang area 0 which connects to all other areas. Okay? So muna siyang tawagon siya as a backbone nato sa multi-area OSPF. Okay? So for OSPF version 3 is usually an OSPF version 2 equivalent, but it uses the IPv6 instead of IPv4. So when you say OSPF version 2, it only uses an IPv4. Okay. So OSPF version 3 has the same functionality also 2, but it uses IPv6 as a network layer, transport, and communicating with OSPF version 3 peers and advertising of IPv6 routes. OSPF version 3 also uses an SPF algorithm similar with the version 2, the computation engine to determine the best path throughout the routing domain. Okay, so OSPF version 3 has a separate process from the IPv4 counterpart. The process and operation are basically the same as in the IPv4 routing but run independently. Okay. Next is the packets. Okay, so there's a video illustration on how our OSPF packets flow. Okay, so aning lima kabuk na to OSPF packets. Hello, the database description, the link state request, the link state update, and then the link state acknowledgement. Okay, so you can view this from our NetAcad. Okay, let me check sa NetAcad. Can you hear the ano? Audio dili no? I think di niyo dung ang kuan audio, but kindly kuan na lang. Uh, Watch it, okay, later. Ang video dili mo lihok. Wait sa ako sa i-check. Okay, just watch it later na lang ha sa kuan. Ito na module sa mga video materials. You need to scan through the resources na to. Okay? So, OSPF packets, to summarize, these are the 5 different link state packets used by OSPF version 2 and 3. Usually, version 3 has a similar, okay? Remember the big difference between the IP, okay? So, type 1 is usually a hello packet, which discovers a neighbor and builds adjacency between routers. Type 2 is the database description, or DBD, which checks for the database synchronization between routers. We have the LSR, which is a link state request. So, requests a specific link state record from a router to router. We have also a link state update, so which updates are specifically request a link state records. Okay. Then we have the acknowledgement. It is used to acknowledge the other packet types. So LSU are used to forward the OSPF routing updates. So LSU packet can contain 11 different types of OSPF version 2. OSPF version 3 renamed several of these LSAs and also contains 2 additional LSA. Okay? So LSU and LSA are often used as interchangeably, but the correct hierarchy is usually LSU contains a packet of the LSA. Okay? So here, as you can see, LSU, under the LSU, you have the LSA mga packet description. Okay? Yung mga ditawag na nag-subtype na description. So we have the LSA type 1, 2, 3, and 4, which is summary of LSA up to 8. So OSPF type 1 packets is usually a hello packet. So hello packets are used to do the following. First, it discovers the OSPF neighbor. Then establish neighbor adjacency. This is used also to advertise parameters on which two routers must agree to become neighbor. And electing a designated router and a backup router on a multi-access network like Ethernet. Okay. So most of the OSPF link-to-link doesn't use that type. Okay, so common siya ka ng designated router and backup router if multi-access network di-connect ka na itong mga routers. So point-to-point do not require DR or BDR. Okay, so unsay instance na point-to-point gamiton when we have direct connection between routers, even if Ethernet, okay, router 1 and router 2 is connected through Ethernet or a serial connection, okay. For the kaning multi-access, if our router is connected to a switch, remember a switch used to connect to the local area network, diba? So there will be a multiple router connected to that switch. Okay? That's why it's defined as a multi-access network. Okay? So this what looks like sa atuang OSPF packet headers, information on a part of your OSPF packet header, the packet type specific data, the hello packet. Okay. Next is the operation. Okay. So there's also another operation video demonstration there for the OSPF operation that covers 7 states of the operation: down state, initial state, two-way, start, exchange, loading, and full state. Okay. So for the operational states, we have the down state in which there's no hello packets is received. So we would know that this would be between the adjacency between the two would uh, doesn't converge. Okay, wala adjacency between them. So router sends hello packet. It keeps sending hello packets. So the transition to initialization state. Okay, for the next step. Okay, so usually that's the first state usually as a default or for starting state sa atong mga router under sa OSPF. Okay, or in operational, let's say the other router is down or naputol atong link, okay, the state will go down, okay, it will di na siya kakita sa adjacency between the neighbor, it will keep sending hello packet until na mo respond. Let's say it's point to point, okay. Sa init state, usually hello packets are received, okay, gikan sa other neighbor, they contain a router ID of a sending router. So transition to two-way state. Two-way state is a state of communication between two routers. It's bidirectional. So in both ways, nag-travel na ng data between two neighbor adjacency na router. So multi-access link, the routers elect the DR and BDR. Okay? So kailangan, importante gini siyang ma-define ang DR and the backup DR. Okay? Transition to start state. XR data is a point-to-point network. Two routers decided which router will initiate the BDB packets exchange. Okay, decided upon the initial DVD packet sequence number. Exchange state. So routers exchange both the DVD packets. If additional router information is required, then transition to loading. Otherwise, transition to full state. If loading state, LSR and LSU are used to gain additional information from the router. So routes are processed using the SPF algorithm. It will go on to transition to the full state. The full state is the link state database of a router that is fully synchronized. So establish neighbor adjacency to determine if there is an OSPF neighbor on the link. The router sends hello packet that contains a router ID. Okay, each of the router has its own router ID. If they are left unconfigured, usually they're going to use their last 6 digit of their MAC address, okay, as their or the IP address. Okay, if there's an IP address, they will usually use the IP address as their router ID. Okay, so hello packet is sent to a reserve all OSPF routes IPv4 multicast address not to 24.0.0.5. Okay, so remember the multicast address range. Remember pa mo, usually it started with 224. Okay, so only OSPF version 2 routers will process these type of packets. So OSPF router ID is used by OSPF process to uniquely identify each router in an OSPF area. A router ID is usually a 32-bit number formatted like an IPv4. Okay, which are assigned to uniquely identify a router among OSPF peers. So when neighboring OSPF enabled router receives a hello packet with a router ID that is not within its neighbor list, the receiving router attempts to establish adjacency with the initiating router. The process router used to establish adjacency on the multi-access network. We have the down to initial state when OSPF is enabled on our router interface. The R1 transition from down to init state and start sending OSPF hello packet out to the interface attempting to discover the other end na router. You have the init state, which is R2 receives a hello from a previously unknown router. It adds R1 ID to the neighbor list and respond with a hello packet containing its own router ID. The two-way state is usually R1 receives the R2, vice versa, and notices the message contain R1 router ID in the list of R2's neighbor. R1 adds R2 also to the neighbor list and transition into two-way state. So both of the R1 and R2 is already receiving both information of both routers. If R1 and R2 are connected with point-to-point, they transition automatically to Xstart. Okay? If R1, R2 are connected to a common Ethernet, kailangan to sila mo select of DR and BDR election. Okay? So, if they are connected to a multicast access, so there will be an election of DR and BDR. So, DR designated router and the BDR, which is the backup designated router, election occurs when the router with the highest router ID or highest priority is elected as the designated router. Okay? So, importante mo na ning multi-access is that na at least na isa ka buok designated router na muna siya ilang basihan sa ilang kuan, sa cost, sa route path cost na basihan. Okay? Okay, dito mag-start na then the rest would have to be calculated again. So, kinsa tong pinakakog cost, most likely would be ma-overlapan sa best path. Okay? So, usually the highest the highest ID, second highest ID would be the backup designated router. The highest would be the elected designated router or the DR, what we call DR. So after the two-way state, routers transition to database synchronization state. This is three-step process. Decide first router. The router with the highest router ID sends the DVD first. Exchange DVDs as many as needed to convey the database. The other router must acknowledge the DVD with an LSA acknowledgement packet. Okay. This sends an LSR. Okay. Each router compares the database information, DVD information with the local LSDB. If the DVD has more current link information, the router will transition to a loading state. After all LSR have been exchanged and satisfied, the router is considered synchronized in a full state. It will update the LSU. Okay, link state updates are sent when a change is perceived in incremental updates for every 30 minutes. For multi-access network can be created two challenges for OSPF regarding of the flooding of LSA. Okay, so remember, most complicated when we have a multi-access than the point-to-point. Point-to-point is just you would know that one router to the next has only one direct uh, connectivity or one path going out padung sa next hop, okay, which is directly connected to a router yapon. Unlike sa multi-access, it would be harder because your 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 route is usually is not really a route, but your switch is going to forward it whenever it's being sent, depending on the destination. If not, usually if kanimo mga hello messages, more makuha na siya, ma-differentiate as more broadcast in which it goes to all other to anyone because it doesn't have any information yet for the destination. So to everyone. So for the point to point, you have a specific destination, which is the next end. For the multi-access, you don't have, which is the switch will have to forward it to all other. Okay, sending out hello packet. So you would have a lot of, let's say, flooding regarding the LSA. Okay, so creation of multiple adjacency. Okay, Ethernet network could potentially interconnect many OSPF router over a common link, creating adjacency with every router would lead to an excessive number of LSA exchange between routers in the same network. So extensive flooding of LSA. So link state routers flood their LSA anytime OSPF is initialized or when there is a change in topology. This flooding can become excessive. Okay. So the number of adjacency usually mo siya yung formula di kuha. Okay. If you have the n is the number of routers, then n minus 1 divided by 2. Okay. So if for example here you have 5 routers, so 5 minus 1 uh, divided by 2. Okay. So you have 5 minus 1, that is 4 times 5, that's 20 divided by 2, that is total of 10 adjacency. Okay. For example 1, if we're going to focus on this router from the top left, this would have an adjacency between this router to the right, below, across the 2. Okay. So na siya daan upat. Okay. So mura siya, if you're going to talk about topology sa basic networking, it's like a mesh type connectivity. Okay. But remember, all the adjacency between this router and this router goes to the switch. Okay. So the illustration here is just pointing out that there's adjacency between them. Okay. And also for the other routers. So LSA flooding with a designated router and increase the number of routers on multi-access network, also increase the number of LSAs exchanged between the routers. This flooding of LSA significantly impacts the operation. Okay, every router in a multi-access network had to flood and acknowledge all received LSA to all other routers in the same multi-access network. The network traffic would become quite chaotic. Multi-access network OSPF elects designated router to be a collection and distribution point of LSA sent and received. The backup will also be elected in case that DR fails. All other routers become the D routers. A D routers is a router that is neither a DR or a BDR, neither designated or a backup. So DR is only used for dissemination of LSA, and the router will still use the best next hop. Okay, so that's it for our module number 1. Any question? Question? There's none? Okay, so again, katong karon pa nakasood, mga late pa, please, please, kanang kuan, kindly check check in your NetAcad if na-enroll na mo sa atong CP3313, and also kindly check sad sa chat group if you belong to the group. If wala mo'y nakita sa inyong Google sa Google chat, okay, wait let me show mine. So, chat. Okay, so this is our Google Chat. You just have to click to your Gmail and natay chat dira, diba? So once clicking that chat, mo ni atong suot. So natay chat, natay spaces, naubos na yung meet. So sa spaces is our kaniyatong ditawag na group nato. Okay? So it is CP3313. It will automatically appear once you're invited. So let me check if you're napabaywa ni accept. Okay? So kani nasendan is like invite but it did not accept it. Okay, so members are those who are accepted my invitation. So this is where we're going to do our chat, questions, announcement, reminders, and so on. Okay? So katong wala ka send, wala ka receive, wala ni appear sa spaces. Okay? So kindly chat your email dire. Then I will try to re-invite you or invite new one. Okay, so Carl, let me add Carl Urakoy. Okay, what else? Salido. Case lang na to. Undion. Tagala. Why? Ano-invite na ka. That's why it did not appear. Lema. Invite na mo. So, for now, kumupando ka, invite mo ka. Okay, so let me check again. View members. Kinsa tong na-invited. Yes, na-invite na ka. Please check. Si mo ha. Na-invite na mo, but you need to see the invite sa atong spaces. Just accept it. Okay? Okay. 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 Kinsa pa may wala gyud. So karon napagyapoy kani sila wala ni sila naka-accept or wala pa ni sila nasud. They are invited but not yet. Okay. Yes, Jim. Can you check Jim Paul if your natakad is already enrolled and also sa imong chat, naba ka sa chat, Google chat na to, kani akong di-display. I think napakadali sa invite, wa pa siguro kani accept. Okay, so kindly accept na lang. One, two, three, four, five, six, 7, 8, 9. 9. Pila dito ka buok? Plus 9, 48. 48 ka buok. Hindi ka na masud sa lab, no? Ano naman eh. Anyway. Ineria, can you check, can you verify if naka sa Google Chat?
Yes, sir. I got an answer.
Sige. Sige. Others na may question?
Excuse me, sir.
Yes, sir.
Pwede ko ay mga yung atong slides nga imong gi-present, sir.
Yes. Yes, pwede ra. Ako lang i-attach dere.
Salamat, sir.
I-attach. Wait lang ha. Okay, so ako nang di-attach sa tong chat group. Okay? So for now, sa tay activity aning chapter 1, but sa tong chapter 2 would have baka tracer activity. Okay? Napay question?
Sir, good morning.
Yes.
Kanang recently lang sir ba like na change among schedule sa usa ka subject which is major namo sir ba.
Mm-mm.
Handled by